In this video, we'll cover single and multi-zone split systems and the requirements for piping, electrical, and controls. We'll show you several system examples using single and multi-zone systems. These examples are good for cooling only or heat pump systems. Single zone air conditioner. The use of a single zone air conditioner is good for one room. The single zone mini split system has two main components. One is the condenser, which will be located outdoors on a pad or attached to the wall with a bracket. And the other component is one of many different indoor fan coils. Here we show a wall-mounted indoor fan coil which houses the evaporator, fan, and filter. The indoor unit attaches to the wall using a bracket that comes with the unit. Just locate a stud in the wall for proper support. Insulated copper line sets will be installed from the outdoor unit to the indoor fan coil. There are some line sets that come pre-charged with refrigerant and with a fixed length that may work for some applications where the distance is 25 feet or less between the outdoor and indoor unit. Otherwise, refrigerant piping will need to be installed and cut to length, possibly brazed at some locations, and or new flares installed on the ends. After making the connection between the outdoor and indoor unit, the non-pre-charged refrigerant line set should be pressure tested to ensure a tight, leak-free system. Next, a vacuum will be pulled on the line set before opening the valve on the outdoor unit, which holds a predetermined amount of refrigerant based on the system capacity. Electrical power will need to be provided to the outdoor unit through some form of disconnect. There are two options for powering up the indoor fan coil depending on model and make. One is that the outdoor unit can provide electrical power directly to the indoor unit along with the communication wire, or the indoor unit can be separately connected to a power source. Since the fan coil produces condensate in cooling mode, there needs to be a drain pipe installed to an improved drain receptor, like the tailpipe of a sink or to the outdoors. Condensate occurs when moisture in the air condenses when drawn over the cold indoor coil and accumulates in a pool of water. If you have more than one zone or room needing air conditioning, then a multi-zone air conditioning system is available in various configurations. Multi-zone air conditioner. With a multi-zone system, you'll need an outdoor unit with an inverter compressor. That's a compressor that can vary the volume of refrigerant to match the current load. There are many different styles of indoor fan coils that you can use, such as floor-mounted, wall-mounted, and ceiling-mounted. Some manufacturers allow up to 9 indoor units for every 1 outdoor unit. This multi-zone mini-split air conditioning system has 3 zones. As you can see, it requires that you run a set of separate copper refrigerant lines for each indoor fan coil. This allows for each room to have their own controller. 2 rooms could be in cooling mode while the other one is off. With the inverter compressor, the reduced demand is not a problem, as the compressor reduces its flow of refrigerant to meet the demand. The old school central air conditioner will either be on or off. Without an inverter compressor, there was no way to reduce energy usage when demand was reduced. If you need more zones, then there are options that allow up to 9 indoor units. Here we show a large home requiring 8 zones. Copper tubing carrying the refrigerant will need to be installed starting at the outdoor unit where the compressor is located. The compressor is the pump that pushes and pulls the refrigerant through the system. The first length of tubing runs from the outdoor unit to a special T-fitting that allows for the refrigerant to go in 2 directions. The refrigerant piping continues to the next T-fitting and then to the third control box. There are 2 copper tubes entering the control box and 2 copper tubes leaving for each fan coil unit, 1 liquid line and the other gas. A 1-ton fan coil will have approximately a 1/4 inch liquid line and a 3/8 inch gas line, while a 2-ton indoor unit may need a 1/4 inch liquid refrigerant line and a 5/8 inch refrigerant gas line. This control box has 3 zones attached to it, so there are 6 copper tubes leaving the box, 2 for each fan coil. This system uses a control box between the outdoor unit and the indoor units. The control box contains electronic expansion valves to control the amount of refrigerant directed to each indoor fan coil based on demand. The indoor coils produce condensate during the cooling process. This water will need to be removed from the system as it collects in the drain pan. The system allows for a maximum of 3 indoor units per control box and a maximum of 8 indoor fan coils for 1 outdoor unit. This makes a complete circuit for the refrigerant from the outdoor unit to all 8 of the indoor units. Next, electrical power will need to be connected to each component of the system, starting with power coming from the electrical panel to feed the outdoor unit. The power will run to a disconnect switch before entering the compressor. This allows a quick method of disconnecting the power when the unit is being serviced or replaced. Next, electrical power, in this case 208 230 volt power, is run to the first control box and then daisy chained to the other 2 boxes. Electrical power for each fan coil is obtained from the control box. We have shown you 3 simple examples of mini split systems, but there are many variations on this, including for commercial buildings where ASHRAE 62.1 ventilation needs to be considered. See our other videos on demand-controlled ventilation and dedicated outside air systems. If you like that video, please give it a thumbs up and subscribe to our channel. Thank you.